In question 9, part 1, we have to first express 1 upon x into 2x plus 3 in partial fractions. So to express this into partial fractions, we'll first write it as, so this can be written as a upon x plus b upon 2x plus 3. Now taking the LCM, so a will multiply by 2x plus 3 and b will multiply by x. And it is equal to the numerator on the left hand side, which is equals to 1. Now, a simple way of finding the value of a and b is we can make either of the terms 0. So initially taking x equals to 0, we'll get, so the bx term will become 0. We'll get 1 is equals to a into 0 plus 3, which is 3. So a will be is equals to 1 upon 3. To find the value of b, we can take the value of x as, well, I think it will become minus 3 upon 2. So if we take x equals to minus 3 upon 2, so this will be 2 times minus 3 by 2 plus 3 plus b into minus 3 by 2. So 2 and 2 will cancel, minus 3 plus 3 will become a 0. A simple way is I just took 2x plus 3 and put it equals to 0, as we have to make the a term 0 now. So x was equals to minus 3 by 2. So this will become 1 is equals to, this will become 0, minus 3 plus 3 is 0, minus, so this will become 3b upon 2. Cross multiplying, we'll get 2 times 1, so that will become 2 is equals to minus 3b, and b will be is equals to minus 2 upon 3. So the final answer will be, as a is 1 upon 3, so this will become 1 upon 3x minus 2 upon 3 and into 2x plus 3. In part 2, we have a differential equation, which is x into 2x plus 3 into dy by dx is equals to y. And it is given that when y equals to 1, x equals to 1, we have to solve the differential equation and then calculate the value of y when x equals to 9. Now, to solve a differential equation, first you'll have to bring the x terms with dx and the y terms with dy. So bringing y on the left-hand side, we'll get dy upon y. And taking dx on the right-hand side, that will become dx. And x and 2x plus 3 will come in the new denominator. Now, as we have already broken this up into the partial fraction, the answer was 1 upon 3x minus 2 upon 3 into, so that was 2 upon 3 into 2x plus 3 dx, and this was dy upon y. So this was dy upon y. Now, to solve the differential equation, we'll integrate both the sides. Now, integrating 1 upon y, that will become ln of y. Integrating 1 upon 3x, so we can leave 1 upon 3, and integrating 1 upon x, that becomes ln of x. Leaving 2 upon 3 as the coefficient, integrating 1 upon 2x plus 3, will get ln of 2x plus 3. And then you also divide with the derivative of 2x plus 3, which is 2. And we add a constant. So 2 and 2 will cancel out, and we'll have ln of y is equals to 1 upon 3 ln x minus 1 upon 3 ln of 2x plus 3 plus c. Now, to find the value of c, we know it's given that when y is 1, x equals to 1. So this will become ln of 1 is equals to 1 upon 3 ln of 1 minus 1 upon 3, and ln of 2 plus 3, that will become 5 plus c. ln 1 is 0. So both of these terms will cancel out, and minus 1 upon 3 ln 5 will go on the left hand side. So the value of c will become 1 upon 3 ln of 5. Now we have the value of c. So this is ln of y equals to 1 upon 3 ln of x minus 1 upon 3 ln of 2x plus 3 plus 1 upon 3 ln of 5. Now we have to find the value of y when x equals to 9. So in the first step, we can just simply substitute, as 1 upon 3 is common. So we can write it as 1 upon 3 into ln of 9 minus ln of, so 2 times 9 is 18 plus 3 is 21 plus ln of 5. Now substituting this in the calculator. So when you substitute this in the calculator, we'll get ln 9 minus ln of 21 plus ln of 5, which is 0.762, and then dividing this answer by 3. So we'll get 0.254. So ln of y is equals to 0.254. And then to find the value of y, so y will be equals to e to the power 0.254. Substituting this in the calculator, we'll get e to the power 0.254, which is equals to 1.289. So y will be equals to 1.289. And as we have to give our answer to three significant figures, so the final answer will become y equals to 1.29.